Good afternoon, everyone. Welcome to Flip Lectures in Chemistry. Today, we will be talking about an important foundation in chemical reactions. In most chemical reactions, example is after combustion, we might wonder where the forms of matter are. Though the forms of matter are no longer present in its original form as they disappear after the reaction, all of the mass of the forms of matter are still present, but they are already in different forms. This condition was first explained by the French chemist Antoine Lavoisier. According to Antoine Lavoisier, no new matter is created nor destroyed in this planet. Thus, in any chemical reaction, matter cannot be created nor destroyed. He also added that the total amount of mass in planet Earth remains constant, and it is merely changing from one form to another form. This is perhaps one of the reasons why Earth is considered a closed system, but we'll talk more about this in our class tomorrow. Going back to combustion earlier, the forms of matter involved in the reaction did not disappear after all. For example, when combustion started, oxygen gas reacted with a natural gas, specifically methane, to produce water vapor and carbon dioxide gas. And if you mass the reactants oxygen and methane, it would equal the mass of the products water and carbon dioxide. And we can remember the law of conservation of mass with this. We will further discuss this tomorrow. All chemical reactions are represented by a chemical equation. And in a chemical equation, we have the reactants that appear on the left side of the equation. Aside from the reactants, we also have the products. The products are the ones that appear on the right side of the equation. The states of the reactants and products are also written in parentheses to the right of each compound to tell us their forms. For example, we have G, which is for gas, for example, corresponding to the given form of matter, which is methane. It also applies the same for the case of oxygen, carbon dioxide, and water vapor. Since the law of conservation of mass applies to all reactions on planet Earth, all equations must be balanced. And to balance chemical equations, coefficients are actually inserted to balance these equations. Subscripts and coefficients give different information. For example, for the case of subscripts, they tell the number of atoms of each element in a molecule. So for example, given the chemical formula H2O, this means that we have one molecule of water. So aside from that, the subscripts actually tell us the composition of the chemical formula of H2O. This means that H2O has 2 atoms of hydrogen and only 1 atom of oxygen. Aside from subscripts, we also have coefficients. Coefficients, on the other hand, tell us the number of molecules. For example, the combination of the atoms of hydrogen and oxygen produces this chemical formula. 2 here is actually the coefficient. This means that we already have 2 molecules of water. Thus, the composition of this chemical formula is now 4 atoms of hydrogen and 2 atoms of oxygen. Other symbols used in chemical equations also include the plus sign, which actually separates 2 or more reactants or products in the chemical equation. Aside from the plus sign, we also have the arrow. The arrow separates the reactants from the products. Aside from the arrow, we also have opposite arrows. Opposite arrows separates reactants from the products and indicates a reversible reaction. Symbols are also used, such as, for example, for elements or even in compounds, we have S. S is for the solid state, L is for the liquid state, we also have G for the gaseous state, and we also have AQ which means that it is identified as a water solution or is dissolved in water. So all of these are necessary for tomorrow's discussion. So once again, thank you and good afternoon.